All right, so we're moving on this morning to alcohol and alkanol. Any organic compound that we see, Javiana, that has a OH on it, that compound is called the alcohol. So any organic compound that we're seeing that's carbon bonds with an OH, and what do we call the OH class? Anytime we see this OH attached to a carbon, this OH is called hydroxy, and it tells us that we have a alcohol. Now, there are various types of alcohol. So we are going to look on methanol. Methanol has, anytime we see the word meth, how many carbons does this compound have?
One.
It have one, and it has a OH, so this is methanol. And the formula for methanol, general formula is CnH2n plus 1 OH. So the formula for methanol is CH3OH. How do we get this? N is 1. So C1, we don't write the 1. 2 times 1 plus 1 is 3. So it's CH3OH. So that's methanol. After methanol, we have ethanol. Ethanol has 2 carbons and 1 OH attached. So in ethanol, it means N is 2. So C2, 2 times 2 is 4 plus 1, CH5OH. Then we have propanol. Propanol has 3 carbons. And the molecular formula is C3. 3 times 3 is 6 plus 1, 7. H7OH. All right, so now you're going to do butanol. Butanol has 4 carbon. Then you're going to do pentanol. Pentanol has 5 carbon. And then we do hexagon, which has 6 carbon. So 4 carbon, 5 carbon, 6 carbons. So quickly do that for me, please. Draw it and write the molecular formula. So in butanol, we have 4 carbons at the OH, and then each carbon needs to be bonded 4 times. So I put on H to make it up. So it's C4. I count all of these H's. I'm going to get 9 plus the OH. Pentanol, 5 carbons. C5H11 OH and hexagonal 6 carbon. C6H13OH. So remember yesterday when we did characteristics of homologous series, we said that when we move from one compound So the other, they differ by CH2. So notice here, C goes up by 1, H goes up by 2. That's what we mean that when we move from one organic, one member of it to next, or in some books use the preceding or succeeding member, it changes by CH2. That's what we mean. Clear? So yesterday we said that it is the functional group, which is the OH, that is going to make a substance. So the functional group we defined yesterday. Anybody can define functional group for me? So it's the atom or atoms responsible for a organic compound chemical property. So what this means, it is the OH that is going to be responsible for how alcohols react. This OH is the foundation for how alcohols react. So it's because of the presence of the hydroxy group that it's going to make the compound have its both its physical property as well as its chemical property. So OH, so when we look on OH, right? OH is a covalent bond. This line here means that it is sharing an electron with hydrogen. So this OH means oxygen is sharing an electron with hydrogen. Now, oxygen is a bully, and oxygen is more electronegative than hydrogen. So it acts as a bully. Electronegativity means once you're more electronegative, it's gonna pull the shared pair of electrons towards itself. So oxygen is more electronegative than hydrogen. Therefore, oxygen pulls the shared pair of electron towards itself. When oxygen does that, right? When oxygen pulls the shared pair of electron towards itself, it's almost as if oxygen had gained an electron. Now, we all know from ions, when elements gain an electron, what is their charge?
Negative.
They become negative. So this oxygen will have a slightly negative charge, and this hydrogen would lose the electron, so it would have a slightly positive charge. Are we clear?
Yes, miss.
My miss, I was looking for Gianna, but I found her. Ready? Ready? So let's go. Oxygen is more electronegative than hydrogen. So this means oxygen is a bully. It takes this pair of shared electron. So this electron that's being shared, oxygen pulls this pair of electron towards itself. And so the oxygen is slightly negative, and the H will slightly negatively charge, and the H will have a slightly positive charge. So let's go. Now, when oxygen is slightly negative and hydrogen is slightly positive, we refer to the molecule as being polar. Do we know any other substance that is polar? Do we know any other solvent or substance that is polar? We did this in bonding. Do we know any substance that's polar? Yes, ma'am. Water is polar. Water is a polar solvent. So what we're saying too is alkanols and alcohols are polar. Clear? Water have the same system. This is a water molecule. What's going to happen in water? Somebody tell me what's happening in water. Same exact explanation. Nobody? Don't be shy. Oxygen is more electronegative than the hydrogen. So oxygen is going to pull the electron away from hydrogen, leaving the oxygen slightly negative and the hydrogen slightly positive. Clear? So water is polar. Clear?
Yes.
Hello? So water has a slightly negative end and a slightly positive end. Alcohol have a slightly negative end and a slightly positive end. Are we clear? Can I clear the screen? Or finish writing? No, as a result of the polarity, hydroxide is polar, right? So here, because it is polar and water is polar, they are two like substances, so they can dissolve. So when we did separation of mixture, we learned that ethanol and water forms a homogeneous mixture, right? Therefore, they are miscible liquid, they dissolve, right? The reason why they are miscible liquids is because they're able to dissolve in each other. So the hydroxy group, the OH, is more electronegative than hydrogen, so it pulls the electron towards itself. The oxygen will have a slightly negative charge and the hydrogen a slightly positive charge, or partially positive charge. The partial negative end of the alcohol will dissolve in the partial positive end of the water, and the partial positive end of the alcohol will bond. So where dissolve is, I'm going to change dissolve here to bond. So the slightly negative end of the alcohol will bond with the slightly positive, negative end of the alcohol will bond with the slightly positive end of the water, and the slightly positive end of the alcohol will bond with the partial negative end of the water. So alcohol can dissolve in water. So alcohol dissolve in water because the partial negative end of the alcohol will bond with the partial positive end of the water, and the partial positive end of the alcohol will bond with the partial negative end of the water. So that's how they dissolve. Clear? All right, so now we're going to do preparation of ethanol. Ethanol can be prepared by the hydration of alkene. Now in hydration, we're adding water. And when we add water, we said to one carbon that was in the double bond, we add H, and to the other, we add OH. So we draw back what we had. The double bond, we put a single bond. We had a H here and a H here. And then to one carbon in the double bond, we will add H, and to the other, we will add OH. So this is ethanol. The reaction is catalyzed with a temperature of 300 degrees Celsius, 60 atm, and we use concentrated phosphoric acid as the catalyst. Now, any ethanol or alcohol products prepared from the hydration of alkene, that substance is not, we cannot drink that alcohol. So the alcohol manufactured in the lab is alcohol that is poisonous to us. So even though it's ethanol, that's not the ethanol we drink. Clear? Any ethanol synthesized in the lab via the hydration of an alkene, that alcohol cannot be drunk. That alcohol is poisonous. No, the alcohol that we drink is as a result of the fermentation of carbohydrates. So different carbohydrate can produce different types of ethanol, which is the ethanol we drink in our alcoholic beverages. Clear? Now, we want vodka, we ferment potato. If we want rum, like Jamaican rum, we ferment molasses, which is a byproduct of sugar cane. We want beer, we can ferment cassava. We want wine, we can ferment grapes, or we can ferment other fruits to get wine. So fermentation of carbohydrate is what we use to produce ethanol. So yeast is added to a carbohydrate mixture. The yeast respires anaerobically and breaks down the complex carbohydrates into glucose. So the first thing that the yeast does is it converts complex carbohydrate to glucose. And then the yeast will also produce an enzyme known as zymase. Zymase is going to convert glucose to ethanol and carbon dioxide. This is an equation we need to swat. So it is 6, glucose is C6H12O6 in the presence of zymase, and the condition is 37 degrees Celsius, and it is a acidic pH 4.8 or 5, and we get 2 ethanol and 2 carbon dioxide. No, the ethanol can be oxidized to form ethanoic acid. Ethanoic acid is something we don't want at all. It's bitter, it's like vinegar. So ethanoic acid is vinegar, really. So we want to make sure that our wine that we make is free from oxygen, because the oxygen will ferment it to vinegar or ethanoic acid. Clear? So we must memorize this. All right, remember we said it is the reaction, it is the hydroxide that is going to determine how elements react. So we're going to be looking on reactions. The behind schedule. We're on reactions of Alkanol. First reaction we're doing is dehydration. So in dehydration, OH is removed and H is removed from an adjacent carbon. So remember, when we're adding water, we would have added water in the form of H and OH. So when we're removing water in the form of dehydration, wherever the OH is, we're going to remove that OH, and H is going to be removed from an adjacent carbon, and a double bond will form between the two carbons. The pen here start act up. I'm just buy the pen other day. You know. All right, so here we have ethanol. Let's do the word equation first. So we have alkanol, and the condition for this reaction is concentrated H2SO4, 170 degrees Celsius. We're gonna form a alkene and water. So here we have ethanol. It doesn't matter where I put the OH, I'm just putting it here for ease. So let's go. It says that in the fermentation of alcohol, OH is removed from the carbon it has, and from an adjacent carbon, we're going to take out H. So we're going to remove water from these two carbon atoms, clear? And then it says that the double bond is going to form between the two carbons. So I am going to have a double bond forming between these two carbons. Can't use white. So I will have a double bond forming between these two carbons. The H's are going to be there still. So that's how I get the ethene. This is ethene, this is ethanol. And I'm going to form water. Clear?
Yes, miss.
Miss Baker, we good?
Yes, miss.
Miss Wilson?
Yes, miss.
So here I draw propan 2-al, prop, 3 carbons. 2 means the OH is on the second carbon. So I draw propan 2-al, and I'm going to dehydrate it. 170 degrees Celsius, concentrated H2SO4. In the dehydration reaction, I'm going to take OH, right? And I'm going to take H from an adjacent carbon. So this is an adjacent carbon, or this adjacent are carbon side by side. So I'm going to opt to take it from here. The carbons that I take the water from, they're going to form a double bond. Clear?
Yes, miss. Yes, miss.
So we're going to do the molecular formula. Ethanol is C2H5OH. And when we dehydrate it, remember we are removing an H and an OH. So we're going to take out the OH and remove a H here. So we end up with C2H4 plus water. If it is C3H7OH, and we dehydrate it, we're removing one H here and the OH. So we're left with C3H6 and water. Clear?
Yes,
In inorganic chemistry, right? Water reacts with sodium to form calcium hydroxide and hydrogen. To balance this equation, we are going to put 2 in front of everything in order to balance this equation. Now, when calcium reacts with water, so sodium is a +1 metal, right? So sodium is removing the H plus ion. The slight H plus ion that we have on the water, that can be replaced by sodium. Now, if we react calcium with water, we're going to form calcium hydroxide. Calcium is a diatomic ion, right? Hydrogen. Clear? Now, in this scenario, to balance this equation, we put 2 in front of the water to balance the equation. Now, it's a similar thing when we react ethanol with metal. So if I react ethanol, C2H5OH, this H, like the H in the water, so one of the H in the water here is replaced by sodium. Clear? So we get NaOH. Clear? Now, this H, which is the acidic H, is going to be replaced by the sodium. So when I replace it, I'm going to get C2H5O, and I get an Na. Hydrogen is being replaced, but hydrogen is diatomic, so we get H2. What am I, solid or liquid? Liquid. Let's put liquid there. Now, to balance this equation, we balance it just like the one up here. 2 in front, so we want H2. We want to put 2 here. Once we put a 2 here to get the H2, we need to put a 2 here. Once we put a 2 here, we need to put a 2 in front of the sodium. So this compound is called, sodium ethoxide. So when the alcohol forms an anion, the anion is called alkoxide. So when it reacts with metal, we form metal alkoxide. The metal in this case is sodium, and the alk have 2 because it's ethanol, so it's ethoxide, right? Now, we replace the H here with a diatomic, with a divalent cation. So we're going to need, just like this, we're going to need 2 OH. We're going to need 2 ethoxide. So we're going to bracket the ethoxide, put a 2 there, and put the Ca, and we also form hydrogen gas. To balance this equation, we just simply put a 2 right there. Calcium ethoxide. That's clear? Alkanol can be converted to a alkanoic acid by a process known as oxidation. All right, so alkanol can be converted to alkanoic acid by a process known as oxidation. Look. So alkanol can be converted to alkanoic acid by a process known as oxidation. In oxidation, we can use acidified potassium dichromate. And if we use acidified potassium dichromate, we observe that dichromate moves from orange to green. We can also use the oxidizing agent potassium permanganate, and potassium permanganate turns from purple to colorless. Clear? Now, in the oxidation process, the carbon with the 2OH, with the OH. So this is the principle. So the carbon that has the OH will lose two H's and bond with oxygen. Clear? So we're going to look for the carbon with the OH, and that carbon is going to lose two H's and will bond with oxygen. Remember, when carbon bond with oxygen, it is a double bond O that is formed. So we look for this carbon with the OH, and that carbon is going to lose these H's and will form a bond, C double bond O, so it looks like this. Clear? And the H's will combine with one of these oxygen to form water. So the carbon that has the OH also has two H attached to it. The carbon is going to lose these two H's and a C double bond O will form. Clear? Do we understand the principle?
Yes, miss.
These H's will go and C double bond, and instead of bonding with the H's, this carbon will now bond with the oxygen. So here we have ethanol. We're reacting ethanol with an oxidizing agent. What we're saying is that this is going to go and this is going to go. When they go, we will form C, where this H is where a C double bond OH is going to come there. So one of the oxygen goes here, and the other oxygen will combine with the two H's to form water. So this is ethanoic acid. Are we clear?